In this video, we will talk about why do we use linked list, which is a dynamic data structure. Before we move on to speak about linked list, let us first discuss what are arrays. We will talk about the low-level representation of computer memory and the limitations of arrays. Then finally, we will talk about what is a linked list and why we use linked list and the differences between arrays and linked list. Let us visualize arrays as cells side by side since they occupy memory sequentially. In most programming languages, array starts with an index 0. So the leftmost side we have index as 0. Which obviously represents the first element of an array. The next element will have index 1, and the following element will have index 2, so on till the last element of an array. Remember that the array occupies sequential blocks of memory. It is imperative that we establish a clear understanding of their behavior, because they are the building blocks upon which we will be developing more complex data structures. We will discuss low-level aspect of computer memory architecture. The computer's memory system consists of number of bytes of memory. Each byte of memory is associated with a unique number that we call it as memory address, which is used to access each unit of memory. Any programming language keeps track of the variable declared and the memory address associated with that variable. For example, if we declare a variable and assign the value 7 to that variable, a memory address will be associated with that variable, and the value assigned, which is in this case 7, will be stored at that memory location. In the same way, if we declare a variable y and assign the value as 12, another memory address will be allocated to the variable y. And the value assigned, that is 12 in this case, will be stored at that location. But let us take an example of top 5 videos on YouTube, where we want to keep track of top 5 videos based on their views. For example, 7, 4, 12, 8 and 3 million views respectively. It would not make any sense to declare 5 different variables. Instead, we would use a single variable and use index numbers to refer each value. That is, we can store these values one after another in a contiguous memory locations, and this representation is known as an array. For example, we are trying to store integers. And let's assume that a programming language takes 2 bytes to represent integers. Since we have 5 integer values to be stored, it would take 10 bytes to represent this array. But we say that this array will store 5 elements even though it requires 10 bytes. Each location within an array is referred to as a cell, and we can use indexes to access each cell. Usually, the index of an array starts from 0. Then the next cell is 1, and so on. So we can find element 7 at index 0, element 4 at index 1, element 12 at index 2, element 8 at index 3, and element 3 at index 4. Here the size of the array is 5. Let us look at another example. Arrays are not only limited to having integers. Here is an array which contains 6 characters. You can find character L at index 0, character O at index 1, and so on till character n at index 5. Arrays have few limitations or drawbacks. The first limitation is all the data stored in an array must be of same type. An integer array can contain only integer elements. A string array can contain only characters. In the same way, an array of any object must contain elements of the same object. Let us look at another limitation of an array. The second limitation is that an array has to have a fixed size. That is, the number of elements an array can store, and the size of an array has to be decided at the time when an array is created. And once an array is created or declared, its size cannot be changed. So once the array exceeds the maximum number of elements it can store, the only possibility is to resize the array to allow more memory. Remember, we just cannot have an infinite amount of sequential memory. The other aspect is that the array stores data sequentially in the memory. Now let us talk about linked list. Linked list is a collection of elements where each element is represented as a node, and each node contains the data or element along with the link to other node. Node is a location in computer's memory. For each element, linked list creates a node in the memory. So for element 7, a node is created which contains the data value as 7 and whose memory location or address, let us say, is 4120. Then for element 4, a different node is created whose memory address, let's say, is 4125. Then for element 12, a new node is created whose memory address, let's say, is 4132, and so on. Now let us talk about the link part of the node. Node contains data along with the link to the next node. So, link actually stores the memory location or memory address of the next node. So here in our collection of elements, the first element is 7. So the first node contains the data as 7 and the link to the next node. That is, in this case, we have element 4, that is the second node whose memory address is 4125. So link of node 7 stores the memory address of node 4. That is, in this case, 4125. So a link is created between node 7 and node 4. In the same way, we have element 12, whose memory address is 4132, which is stored in the link part of node 4, because element 12 is the next element after element 4. And for element 8, whose memory address is 4137, is stored in the link part of node 12, as well as the element 3, whose memory address is 4140, is stored in the link part of node 8. And finally, the link part of node 3 will be null, since there are no more elements in the collection, and the node with element 3 is the last node. So this is how a linked list for the collection of elements will be created. Remember that arrows or links are only for visual imagination or representation. It is actually the memory address or the memory location of the next node, which is stored in the link part of the node. There is also an important observation to be made here. The memory locations or addresses of nodes are not contiguous or may not be contiguous, that is side by side, when compared to the arrays which uses sequential memory locations or memory addresses. So, how will we access the collection of elements? For example, in arrays, we use index to access the collection of elements because the arrays uses sequential memory locations. But in linked list, how will we know which element is next to the other element? Or how will we access the collection of elements? This is done through links in the nodes, which stores the memory address of the next node. So now let us talk about why do we use linked list. The size of an array is fixed. That's the problem. But why? In reality, we are not sure of the number of elements we will be needing. For example, today I want to store top 5 YouTube videos. But later I want to store top 10 YouTube videos. So earlier I have created an array to store 5 elements. But now I have to resize the array to store 10 elements. We were not sure of how many elements the user needed for the array. If we are sure of the number of elements, then we can use arrays. So this is the problem or the limitation of using arrays in reality. If we assume an arbitrary size, then that size may be less or insufficient. On the other hand, it may be excess or the memory allocated may be wasted. So we need a data structure which should grow or shrink in reality or at the time program is running. That is, we should be able to add any number of elements or delete any number of elements in our data structure. The other limitation of an array is that it stores elements sequentially. But we also need a mechanism through which we can efficiently utilize the computer's memory. Let us now discuss the differences between arrays and linked list with respect to memory. An array stores data or elements sequentially in the memory, whereas a linked list will contain a node. A node is a location in the memory which stores data along with the link to the other location in the memory. These nodes are not sequential memory locations, and by using links of the nodes, we can efficiently utilize computer's memory. So, to represent the same set of element as a linked list, a node is created in the memory along with the data, that is 7 in this case. A link to the next memory location is null right now, which represents that there is no link right now. And then for the next element, a new node in the memory is created, which has the data as 4 in this case. And now the link from the first node, which contains element 7, is assigned to a node which contains element 4. For the third element, a new node is created in the memory with the data as 12. A link from the previous element, that is node 4, is assigned to node which contains element 12. The same procedure is followed for the fourth element and the fifth element. The node with the fifth element also has the data, that is, in this case it's 3, along with the link to the next memory location. But since this is the last element of the linked list, the link to the next node will be null. That is, it does not point to any other memory location. But suppose if we have to have a new element in the linked list, we can create a new node in the memory and assign the link of the last node to this new node. So this is how we can increase the size of the linked list as well as efficiently utilize the computer's memory. If you observe, we are allocating memory whenever we need it for the elements, as well as we will be able to remove the nodes by changing the links. So this data structure, that is the linked list, is more flexible than the array. In this topic, we have seen arrays, which uses sequential memory locations. We have seen the limitations of arrays and how linked list uses nodes to store elements in the memory. Here we have just seen the basic idea of the linked list. In the coming videos, we will look in detail about the linked lists.